Yeah, good morning, one and all. So today we will discuss about hybrid ARQ in the downlink. Okay, by this time, you might have studied what ARQ techniques, that is automatic repeat request in the computer communication, right? Why this is required? First, let us try to understand. So, in any wireless network, due to the effects of channel fading and interference from the neighboring cells, okay, it is, I can say, nearly impossible to guarantee error-free transmission, irrespective of what type of channel coding you use. Okay, I repeat once again. I said in any wireless network, due to the effects of channel fading and the interference from the neighboring cells, okay, it is nearly impossible to guarantee 100% error-free transmission, okay, irrespective of what type of channel coding we have used in the system. Okay, so as we know, the channel coding techniques with the less coding rate, okay, will be able to provide a most or more robust transmission. As the coding rate decreases, I can say it provides more robust transmission, right? But at the same time, as the number of bits are reducing, so we will be losing the same amount of power. Okay, so power efficiency we will be losing because we are transmitting few bits with the same amount of power. Okay. So to overcome these problems, the solution is, one approach is this hybrid ARQ. Okay, that is it combines two things. One is the forward error correction and the retransmission in the single framework. So as we are aware what FEC is, right? So forward error correction. So forward, as I said, hybrid ARQ protocol combines the forward error correction and the retransmission, that is ARQ, within a single framework. So what is the purpose of FEC, or what FEC is? So FEC, that is a forward error correction, is a coding technique that uses redundancy bits to protect the data being transmitted. Okay, basically it is an error correction mechanism. Okay, so when the transmission conditions are poor, the decoder which is implemented in the receiver is able to use these redundancy bits to repair the errors and recover the original data sequence. I can say original information. Okay. So this forward error correction is implemented in the physical layer. Okay, it is implemented in the physical layer, and as a part of channel coding technique. In LTE, we use turbo coding as the forward error correction code with the coding rate of 1/3. Okay. So as I said, this forward error correction helps to reduce the number of retransmissions required for certain level of signal to noise ratio. Right? So the sequences that cannot be recovered will be retransmitted by the retransmission technique, that is ARQ. Okay. In actually LTE, we use adaptive FEC technique. It will adjust the amount of redundancy bits used according to the propagation conditions. So depending upon the propagation conditions, it will vary the number of redundancy bits. Okay. So with that, the redundancy overhead is minimized under good propagation conditions, and we can say when the propagation conditions are good, the throughput will be maximized. Okay, so this hybrid A-ARQ operation will be a part of the MAC layer. Okay. So this is about FEC. As I said, hybrid A-ARQ is combination of FEC and as well as retransmission technique, that is A-ARQ. I told what is FEC, right? The purpose FEC is a channel coding technique. I said it uses the redundancy bits to protect the data being transmitted over the channels, right? So based on the propagation conditions, right, the receiver, the decoder which is implemented at the receiver uses these redundancy bits to repair the errors and recover the original information. Whether 1/3 means the coding rate is 1/3. The type of code channel coding used is turbo coding in LTE. Okay. So this is all about FEC, what I can say. Okay. And the next is A-ARQ, I said, right? So A-ARQ, that is what automatic repeat request, right? It is the second component of the hybrid A-ARQ, and this retransmission technique, the A-ARQ, is implemented in the link layer, that is radio link layer, RLC, and it uses the technique called CRC, cyclic redundancy check, or parity bits to detect the errors in the sequence, okay, of data at the receiver side. Right? So A-ARQ is what? It is implemented in the link layer, and it uses techniques like CRC or parity bits to detect the errors in the sequence of data at the receiver side. So the receiver requires this error detection to acknowledge the receipt of transmitted sequence. So this acknowledgement will be provided to the transmitter. The receiver will decide whether the received sequence have error-free information or not. So depending upon that, it sends positive acknowledgement and negative acknowledgement. Means when the received packet having no errors in that packet, then it will send a positive acknowledgement. Okay, if the received packet is having errors, then it will send a negative acknowledgement to the transmitter. And if the transmitter receives a negative acknowledgement or does not receive any acknowledgement after a certain amount of time, we call that as timeout, then it will transmit the same sequence. I think these A-ARQ techniques you might have studied in your computer communication network, like stop and wait, right? So these are the three techniques which you have studied. Just I kept this slide here for recap. Okay. First one is stop and wait protocol. Second one is go back and protocol. Third one is the selective repeat protocol. So what happens in stop and wait? It will transmit the packet and it will wait for the acknowledgement. Okay, when it gets the acknowledgement, then it will transmit the next packet. Okay, so that is what happened in the stop and wait protocol. This is what is shown here. If a transmitter receiver, packet 1 transmitted to the receiver, so the receiver will send the acknowledgement. So after receiving the acknowledgement, the transmitter will send the second packet. So here shown with different color, means it says error. The packet which the receiver receives, packet number 2, has some errors. So it will send the negative acknowledgement to the transmitter. So now what transmitter will do, it will transmit the same packet again to the receiver. Right? Even in second time also, it is receiving with errors. Again, it will send the negative acknowledgement to the transmitter. So again, it will send the same packet back to the receiver. Right? So now the receiver has received the packet which is having no errors in that. Now, when it sends a positive acknowledgement, then the transmitter will send the next packet, that is packet 3. That keeps changing, right? This is what happens in stop and wait. Since it will wait until the positive acknowledgement gets. Okay, the transmitter will wait until the positive acknowledgements it gets. But till that, it keeps transmitting the same packet. That is what is happening in the stop and wait protocol. So in case of go back to N, so here it is possible to send more than one packet. Okay, and see it is said right here. I have taken the value of N as 5. Means in one stage I can send 5 packets. Then after that it starts sending the acknowledgements. Right after 5 packets. So when it starts receiving the acknowledgement, so for some packet, if the receiver finds that there is an error, then for that particular packet it sends the negative acknowledgement. Then it restarts again transmitting the packets from the beginning. Okay, so that is what is happened in this. In the go back to N, right? So packet 1, 2, 3 is sending a negative acknowledgement. So it will be not sending that 3 packets. Then packet 3 will be sent. Then 4, 5, 6. Again for packet 7 it is receiving the negative acknowledgement. So again, so 5, 6 plus 4, 5, 6 will be left out. Then again it starts transmitting 7, 8, 9 and so on. So in case of selective repeat, what happens? Only it will send the packet which is having the error. Okay, only that packet will be retransmitted. So these are the basic, what I can say, H-ARQ techniques which are used in the communication system. Okay. Just to have a recap, I just gone through this. So that is what is shown here. That I said that there are 3 types of automatic repeat request techniques. One is stop and wait. Second one is go back to N. And third one is selective repeat. Right? So these techniques differ in the action they perform while waiting for acknowledgements and in the way they handle the timeouts or receptions of the not acknowledgements. Right? So in the, as I said, in stop and wait, it transmits packet and waits for the acknowledgement. Only when it receives the positive acknowledgement, it will send the next packet. Right? So in case of go back and selective repeat, right? So it is possible to send a sequence of multiple sequence without waiting for the individual acknowledgement. They differ. Let's go back to N and selective repeat differ in the sequence which it gets a non-correct packet, right? In case of go back to N method, it starts retransmitting restarts the transmission of all the sequences. But in case of selective, it sends only the particular packet which has received error. From that packet, it starts sending this one. So there are 2 different types of hybrid H-ARQ techniques. Okay, there are 2 different types of hybrid H-ARQ techniques. So one is we say type 1. Okay, chase combining hybrid H-ARQ, and another one is type 2 incremental redundancy hybrid H-ARQ. Okay, these are the 2 different techniques which are used in LTE. Okay, even these 2 techniques are used in HSPA network also, that is high speed packet access network. So what is chase combining, right? So it resends a type 1 chase combining hybrid H-ARQ technique. will always resends the same sequence of data for every retransmission until the success or until maximum number of retries is reached. Okay. It is similar to stop and wait only. So every packet received with errors is completely discarded, and this version, it is very easy to implement, and it requires very little interaction between the FEC and the ARQ. As I said, FEC is a channel coding technique which is implemented in the physical layer, right? ARQ is a error detection technique, so which is used in the link layer. So little interaction is required between FEC and ARQ in this type, right? So as I said, it repeatedly I think my internet connection is not proper. Okay. I think, am I audible? Audible? Hello? Or is there any disturbance?
No, sir.
It is audible?
You're audible, sir.
Audible.
Yes, sir.
As well as. Okay, so as I was telling, in LTE, there are two types of hybrid ARQ techniques. One is type 1 that we call chase combining hybrid ARQ. Second one is incremental redundancy hybrid ARQ. So what happens in type 1 chase combining hybrid ARQ? It always resends the same sequence of packet for every retransmission until it gets a positive acknowledgement or it reaches the maximum number of retries reaches, right? Every packet received with errors will be completely discarded. Okay. As I said, this type of technique implementation requires less complexity, and it also requires less interaction between FEC and ARQ. Okay. Since this method, right, repeatedly retransmits the same data and discards the previously received data, right? So with that, I can say this is somewhat inefficient because even if there is some bits in errors, so that still contains the valuable information that will be lost. So this we call type 1, right? So in the same frame, with the same redundancy information is transmitted for each transmission, and it is a soft combined at the receiver to exploit the time diversity. So this is known as the chase combining. In a single frame, okay, in a single frame with the same redundancy information is transmitted for each transmission, and I said it is soft combined at the receiver. So that is done to exploit the time diversity. Okay, and I said this technique is known as the chase combining, and this method is very popular, and it will be implemented for user equipment where the complexity of designing this technique is simple and cost will also reduce. So this is about the chase combining technique or type 1 chase combining hybrid ARQ. So next one is the incremental redundancy. As I said, in case of type 1, it keeps retransmitting the same data, right? So that is inefficiency, I said. So to overcome that, this technique uses a retransmission sequence that contains mostly parity bits. Okay. So rather than resending the original sequence, it will send only the part of the parity bits. So these redundant bits are soft combined with the previously received data, okay, to create the lower code rate of FEC. So as we know, the lower the code rate, it will be more robust, right? So this process is known as the incremental redundancy. Okay. So each retransmission will increases the amount of redundancy, and therefore the chance of successfully decoding the sequence is higher. Okay, and this technique provides a flexible level of protection that adapts itself to the time varying channels. But this technique is more complicated to implement because it requires a close collaboration between FEC and ARQ. So that is the and it also requires buffers. Okay. So to have a better understanding about these two techniques. So what I said here, only this one. So let me start with this diagram. Okay. So this is the ARQ. What I said. See, packet one, right? This is a transmitter and receiver. So packet one will be sent. So the receiver receives that packet with error. Then it sends a negative acknowledgement. Then again, the transmitter will be retransmitting the same packet. Okay. Even second time also it receives with error. And it sends the negative acknowledgement to the transmitter. So next time it transmits the same packet, right? Then when it receives the receiver a packet without error, then it sends the positive acknowledgement. Then it will the transmitter sends the next packet to A, right? So as I said, ARQ is implemented in the radio link layer, right? This is about one I can say. The next one is incremental redundancy, right? So what happened in this is, see packet one, the transmitter will send the packet one. That is the TTI, means the transition time interval, right? That is the duration of one subframe, which is equal to 1 millisecond in LTE. So it will be transmitting the packet from transmitter to the receiver, so with error, right? So now what is happening? It receives with error, no? So the receiver will send the negative acknowledgement to the transmitter, right? So now the transmitter will send the another packet, right, with only the redundancy bits, that is written as P1B. Okay, it will not send the same packet. So now also it is receiving with error. So what it will do, it will combine with the previous one. See, PA1 is the first packet, P1B is the second packet. So it will combine the previous one. And still it is error, no? It will send a negative acknowledgement to the transmitter. It will send another packet with some more parity bits, right? Then still it is receiving the packet with errors. So it will combine 1A, actually it is 1A, okay, 1A, 1B, 1C. So it keeps combining at the receiver. That is why the buffer is required. Okay. Now it will be, after combining, it finds that the packet is fine. Then it sends a positive acknowledgement to the transmitter. So it keeps repeating that process. So as I said, hybrid ARQ is a technique. When the receiver gets the new data with some errors, then it will try to make corrections. Right? If the errors are minor, right? But if the error is not minor, then it sends retransmission request to the sender. So after getting the data again, it will combine the new received data with the previous erroneous data. So this is what is happening in the hybrid ARQ. Yeah, I will come back to this TTA bundling and all. As of now, I think not record. Okay, anyhow, just to know, means instead of here sending acknowledgement after every 4 subframes, so in the TTA bundling, what happens? The RV means it is uh, a reduced version, okay, redundancy version. So RV means redundancy version. So means each time it sends a different versions, right, with the parity bits. So those will be sent. Means how many negative acknowledgements it gets, so many will be sent in a bundle. So actually for sending this acknowledgement to the transmitter and again retransmitting the information back to the receiver, in case of delay sensitive applications like voice and all, is not acceptable, right? For other non-delay sensitive applications, it is fine. That is what said. So just to get some more information about this chase combining and other things, I have shown with a different diagram. As I said, at the transmitter side, it keeps transmitting the packets, right? And I said it uses MRC technique, that is the maximum ratio combining. Okay, information packet transmission 1, 2, 3, 4, and so on, along with the parity bits will be transmitted to the receiver. It uses the MRC technique to get back the original information. So that is what happens in chase combining. So in case of incremental redundancy, as I said, for every transmission, it will be not using the same packet. It will be using the different packet. That packet contains the uh, redundant parity bits. Okay, so with that it is possible to, and it will combine also at the receiver side. So that is what happened in incremental redundancy. So it is just an overall idea, big picture of the hybrid ARQ process, what I can say. So multiplexing and assembly entity from this one. So each hybrid ARQ process has this. It has a buffer, right? And then this is the transmitting node, current transmitting node. Then H-ARQ feedback. Then incremental redundancy version, that packet will be sent back. So let me say about this in detail. So as I said, this hybrid ARQ process, right? That depends on whether it is FDD or TDD. As I said, in LTE, we have two options of duplexing, right? FDD and TDD. And whether it is for downlink or uplink. For each link and for each type of duplexing technique, the process of hybrid ARQ is different. Okay. Now, let me consider the FDD and downlink, this one. The type of duplexing is FDD and downlink transmission. Okay. For that, the time interval between the two successive hybrid ARQ transmissions is 8 milliseconds in LTE. Okay. So, there is one hybrid ARQ entity in the ENB for each user equipment that maintains the number of parallel hybrid ARQ processes. Okay. And we use asynchronous hybrid ARQ protocol for this FDD downlink transmission. Means after 8 hybrid ARQ processes, the receiver can send the acknowledgement to the transmitter side. Okay, so that information will be sent through PDCCH, that is physical downlink control channel. Okay, so even it need not be in order. Means the processes, as I have written, hybrid ARQ process 1, 2, 3, and so on. Those processes need not be in order for this asynchronous process. But for synchronous, which is used in TDD, it requires a specific order. Okay, so as I said, we use N channel stop and wait protocol as the hybrid ARQ protocol because it offers a low buffering requirement and a low acknowledgement or negative acknowledgement feedback overhead. Okay, so this asynchronous hybrid ARQ, okay, provides channel quality measurement at the instance of retransmission. So, which is able to provide higher throughput with rescheduling or changing the modulation and coding scheme. So, that is why I said adaptive hybrid ARQ. Okay, adaptive hybrid ARQ is what we will be able to change the modulation technique and as well as coding technique for that. This is for the table which shows for TDD mode. Okay, how many number of hybrid ARQ processes in the downlink is determined based on the uplink downlink configuration. So here there are totally 7 configurations. Okay, TDD uplink downlink configuration, and for each configuration, what is the maximum number of ARQ processes? Okay, for configuration 0, it is 4. So minimum is 4 and maximum is 15 hybrid ARQ processes are allowed in one stretch. Okay, that is for configuration 5. So let me discuss this uplink downlink configuration in the next model. I think it is there as part of this one. So this is what I wanted to say, right? See, one frame is 10 milliseconds and I have 10 hybrid ARQ processes right? I said the acknowledgement is means 8 maximum 8 hybrid ARQ processes are used in this asynchronous FDD mode, right? See here, this is the first transmission, right? Acknowledgement will be received after fourth hybrid ARQ process, okay? And again, the next retransmission starts after hybrid ARQ process 8. Means this is the second transmission. Hybrid ARQ process starts at 9, right? So as I said, this asynchronous, which is used in FDD and downlink mode, right? So it is possible for the ENB to avoid potential collisions of hybrid ARQ retransmissions with other high priority scheduled transmissions. We say persistent scheduling. Even let me discuss while discussing about scheduling, what is persistent scheduling and all. Okay. So asynchronous hybrid ARQ requires more overhead. So because the receiver will not be knowing ahead of time what is being transmitted and when the retransmission will occur. As I said, the retransmission need not be in order. Okay, it can take any this one. Then the maximum, okay, the maximum number of hybrid ARQ transmissions of each transport block is configured by the RRC layer. As I said, in case of asynchronous FDD mode, the maximum number of hybrid ARQ retransmissions used is 8, right? And it is different for TDD mode. That depends on uplink downlink configuration, I said, right? I given this table. And as I said, when the maximum number is reached, when the maximum number of hybrid ARQ retransmissions are reached, okay, if it is not successful transmission of the transport block or the transmission is in error, then this hybrid ARQ acknowledgement signaling, right? Then it will be handed over to the ARQ, that is radio link control layer. The ARQ protocol will be triggered to handle this error event. In a nutshell, to understand LTE, that in downlink FDD mode, okay, the type of hybrid ARQ technique used is N channel stop and wait hybrid ARQ protocol, okay, and I think this diagram is more appropriate to understand how the process is happening. Okay, along other than this, I have taken other examples also for better understanding. I think you can read this diagram as an example in your this one. Okay, so the time interval is what, 8 milliseconds between successive means maximum number of hybrid ARQ processes used in FDD asynchronous mode, that in downlink is 8. And for every 4 hybrid ARQ processes, the acknowledgement will be sent. So if you have any questions, you can ask me. And it is very depth even in case of uplink. So as I said, with the TDD, it is more complex. So many configurations. For each configuration,